All right, welcome back to the final part of the endocrine system, so part 6. So we're going to start transitioning from the endocrine system into the reproductive system. And one of the things I really wanted to emphasize here is just how much of a continuum some of the things in development can be. So basically, the influences that hormones can have on fetal development and therefore the reproductive systems. Okay, so let's just talk a little bit about how we define sex and gender, right? It is not as simple and straightforward as some media will have you believe, right? Depending on the studies that scientists do, there's multiple different ways that you can define this. So, for example, there's chromosomal sex. So that determines whether or not a person has an XX chromosome or XY, right? XX being female, XY being male. However, we're going to see in a little bit, sometimes that doesn't work out quite like that. So it can get a little confusing. Or then you can go, okay, well, what if the person possesses either ovaries or testes? Again, that is one definition, sure, but what if they don't, because developmentally they didn't develop, so then what happens? Then along with that sort of is the next one, gametic, where females produce eggs, male produce sperm, but obviously there can be problems there too. Hormonal sex, females tend to have higher estrogen levels and low testosterones, and males show the opposite pattern. Again, that is another definition. May not always be as straightforward as we think. Then there's morphological sex, that refers to differences in body types between males and females. In males, especially like even in humans, right, tend to be larger than females, but not all. Males, again, in humans, although not all, but males tend to have a less pink hue to their skin. Females tend to have more superficial capillary beds than males. And then body shape also tends to differ between males and females. So your typical males and females, right? Where males tend to have broader shoulders, narrower hips, and vice versa for women. And then there's always this idea of behavioral sex. Some of that is more used in the animal kingdom, but there's sort of that idea of like, what is male typical behavior versus female typical behavior. A lot of that sometimes is used, that distinguishing characteristic is used in like children, like do they play with, what kind of toys do they play with? It's been an area of study. And then, of course, in humans, we have other categories as gender. So how do you so, for example, gender identity reflects the gender or the sex that the individual feels themselves to be, right? Which may contradict one of those other definitions that we saw above, a moment ago. Then there's gender roles, and these are some more cultural kinds of things that we depending on your culture, you put on a certain gender. So whether that is sort of your 1950s kind of housewife that, male goes, earns a living kind of thing, or, other cultures around the world have different divisions of labor. But there are certain expectations in those gender roles. Again, those are culturally based rather than inherent to the human species. And then there's obviously legal sex, which is what has gotten so much attention lately. But that's basically what the government recognizes you to be. Okay, so let's talk a little bit about like hormones and then how we get sort of your typical either testes or ovaries, male reproductive systems or female reproductive systems. Okay, so in another way of saying that is mammalian sexual differentiation. That is your scientific term there. All right, so basically two things have to happen. The proper system needs to be activated and the improper system needs to be deactivated. So what does that mean? So in development, there's a point in time where there is something called a bipotential gonad. So every one of us had a bipotential gonad at one point, meaning that depending on the stimulation, this gonad is either going to turn into an ovary or into a testes. It will just depend on the stimulation that it receives, right? The hormone signaling that it receives. There's also a Mullerian duct and then a Wolffian duct, so two different duct systems. The female duct is the Mullerian duct. The male duct is Wolffian duct. That's so the older names for them, named after, again, individuals. And then you have, basically this urogenital sinus, which will eventually become the bladder in individuals. Okay, so this is what I mean. So the proper system needs to be activated. So you have to activate the one and deactivate the other. So in females, the Mullerian system is activated. Good. We activate the female and we deactivate the male. So basically the male duct disappears and then the female one remains. And usually the rest of the uterus, cervix, vagina, also develop in the individual. So what we say is that individual is feminized and demasculinized. Okay. Now in males, testosterone is necessary to stimulate the Wolffian duct system. So you have to have the presence of testosterone to stimulate the Wolffian ducts. However, you also have to have a Mullerian inhibiting hormone. So this is a specific hormone called the Mullerian inhibitory hormone, and that causes the Mullerian duct to then regress. So basically just like regress, it gets reabsorbed into the body. Now, I want to be very clear with you guys. If an individual who is otherwise male, XY male, produces testosterone, all of those things, has the receptors for testosterone, all of those things, but for some reason does not produce Mullerian inhibiting hormone, what do you think happens? Well, if you guessed, that means that the female system is not inhibited and that it also develops, you would be correct. Now, a lot of times it doesn't fully develop or partially develops. There's, a spectrum of like how much it develops in an individual. But there have been some cases where someone, again, who's male, looks male, like a boy, developmentally as a boy, looks male, hits his teenage years, and then all of a sudden starts experiencing really bad stomach cramps. And that's when they find out, well, the individual never had this Mullerian inhibiting hormone. So they have a somewhat functioning uterus that goes through like a minor menstrual cycle, and this individual can experience cramps. So what they usually do, though I guess depending on the individual, I guess you could just leave it. And I guess it depends on the situation, I guess what the anatomy is and like all those kinds of things. Because if you don't want to have uterine lining being shed and not being able to be expelled out of the body, because then it collects in the abdominal cavity wall and that can cause infections. But what they'll do is they'll just go and remove the uterus, and then the individual is, goes along their lives as a male. Like there's no other issues. Okay, but point being, the hormones are super important. You have to have testosterone to masculinize the male reproductive system, so stimulate that Wolffian. Again, we'll see where if you don't have that, the problems it can cause. But for males to have your sort of typical male, phenotype, you also have to have Mullerian inhibitory hormone that stops the production or the growth of the female reproductive system. Okay. Now, I will say this, if we go back here to females, there is no inhibiting hormone necessary for the male reproductive system in a female, right? So basically the default is female. So if you don't have testosterone, you will simply progress with the female reproductive system. Okay. So let's go to the first sort of anomalous sexual differentiation that can occur. Okay. There's something called Turner syndrome, and this is characterized by a lack or damage to the second X in the case of XX, or the Y chromosome. So a person could be XY, but there's damage to that Y chromosome, and basically it's non-functional even though it is there. So technically their chromosomes are XO because that second one is not functional. Okay. Again, because it's not functional, especially with the Y, they're not going to be producing testosterone. And again, without that testosterone, that Wolffian system, that male duct system is not going to develop. So at birth, they look female. Gonads don't develop completely because again, there's only one functioning X, but they are ovaries because again, the sort of that default, if there's no other stimulation, is by testosterone will be ovaries. And generally, however, because those ovaries aren't usually fully developed, they tend to not produce estrogen in the quantities that are necessary to bring about puberty. And then there's usually some other birth defects also associated with this. So they have short height. There's also usually like hearing loss. Brain development can also sometimes be stunted. So the brain doesn't, there can be some cognitive impairments, I guess. There's sometimes problems with the kidney, and the most superficial, at the time of birth, sort of, I guess, visual of Turner syndrome is this webbing of the neck, and I don't know how well you can kind of see that in this baby here, but you can see that extra sort of flap of skin going to the back of the head, going all the way to the shoulders. There's another thing that can happen, and maybe I should have done this in the opposite order, but there's something called, they both end up with the same effect. There's something called congenital adrenal hyperplasia, so an increased growth or increased production of androgens instead of cortisol in the adrenal gland. And this is, again, fetal, so the person is born with it. So basically what this is saying, so remember the adrenal glands will produce some androgens, but in this case, the adrenal gland is not only just producing a normal level of androgens, it's producing like excess level of androgens, especially, and then instead of cortisol. Now, if a male baby is let me back up. If a male fetus is developing its adrenal glands, and then it's producing excess amounts of androgens and excess amount of testosterone, it doesn't become hypermasculinized. It basically looks like a normal baby boy. However, if in a female's body, especially now imagine a little baby, like a little fetus, so before the individual is even born, if their adrenal gland is now producing high levels of testosterone instead of estrogen, what will end up happening is that the female's external reproductive system especially becomes masculinized. Okay, so you can see the clitoris becomes enlarged into like a penis-sized structure. The labia will fuse into scrotum-like organs. So this is what it looks like in this bottom image right here. And there's there's a spectrum of how severe this can be. It can be anywhere from like, the clitoris is enlarged. However, the opening of the urethra is still separate from it, all the way to that urethra actually going through the clitoris or part of the clitoris. So again, it's sort of like this mix of the two external genitalia, depending on how much fetal testosterone the female is exposed to. Okay. Again, no effect on males. They develop normally with the higher levels of testosterone. Now, if the fetus is exposed to androgens, there's another way that this happened. This really was back in like the 70s, I believe. There was something called diethylstilbestrol, I think is how it's pronounced, DES. Right, and here's an advertisement for it. It was given to women to prevent miscarriages, right? And it worked really well. Like it did a great job preventing miscarriages. However, what it did was it exposed the fetuses to high levels of androgens. So what happened was there was like this short time period where a bunch of babies were born, and the females all had this masculinized external genitalia. So obviously that didn't stay on the market as a viable viable solution to preventing miscarriages. There are also other. So let's talk a little bit more about males. So there's a number of different anomalous things that can happen in males. So there's androgen insensitivity syndrome. So basically, individuals who have this, they do not have functioning receptors for testosterone. Okay, and this is probably the most severe case would be like the complete one, and then there's partial and there's mild. So all of these are different, I guess, levels of androgen insensity syndrome. But again, if you don't have a receptor, there is no effect. So it doesn't matter that the person is XY, so they have the chromosomes, because the mutation for the, or I should say, let me back up, sorry. Because the gene for the receptor for testosterone is actually on the X chromosome, interestingly enough, because there's a problem with it on the X chromosome, XY individuals only have one copy of that X, so they don't have a backup copy for it to work. So, long story short, people who have this don't have the receptors for testosterone, and because you have to have testosterone to stimulate the Wolffian duct, and you don't have the receptors for it, guess what? Wolffian duct is never stimulated to grow. So again, without the presence of testosterone, and as far as your body is concerned, if it doesn't have the receptor for it, you do not have that hormone. Even if it's flowing freely, you can't use it. So these individuals develop the Mullerian system, so they become feminized, right? So you can see complete androgen insensitivity. So this a person's external genitalia appear female, but there's no ovaries, fallopian tubes, or uterus. They are often raised as girls. I mean, it really depends on the individual, and usually what happens is they either fail to have a menstrual cycle or they fail to conceive, right? And that's when they find out that, oh, wait a second, something is wrong here. If I guess there was no other tests that were being done, in utero. Oops, back. Then obviously there's partial, and then there's mild. So again, it just depends on like how severe that damage is to the mutation on the X chromosome. If it's a partial mutation, complete mutation, or a mild one. But again, hopefully this makes sense. So either you have some, you go all the way from appearing male to appearing female, and then somewhere in between. Okay. Now, this one is a very interesting one for males. There's an enzyme called 5-alpha reductase. Okay, this 5-alpha reductase is really important in males. It converts testosterone into the more potent form of testosterone called dihydrotestosterone. Okay, and this dihydrotestosterone is critical for the process of genital fusing, so meaning making the scrotum, right? So what happens is when a person doesn't have this enzyme to convert testosterone to the more concentrated or stronger version of it, when they're born, like their genitalia again is sort of ambiguous. So baby, like that newborn baby, they have ambiguous genitalia. It's kind of hard to tell. Well, is this an enlarged clitoris? Is this a scrotum? Are these large labia? What do we have? However, but everything else functions in the individual. So once they hit puberty, there's enough of a surge in testosterone that just by having just more testosterone, it's enough to then fully masculinize the individual. Okay, hopefully that makes sense. So again, at birth, you don't have that more potent form because again, you don't have this enzyme that converts testosterone into dihydrotestosterone. So at birth, there's somewhat of a ambiguous external genitalia. However, at puberty, there's enough release of testosterone, and then the individual undergoes a fairly dramatic change in their appearance. This is genetic. So in some isolated parts of the world, where people, intermarried quite a bit, there's higher concentrations of this, and they even have different names for them. So anyway, and there are some documentaries if you're interested in some of these populations. Okay, here's a case study of one individual. You can kind of see this back in 1973, is published in the journal Science. It's an individual who had 5-alpha reductase deficiency. So you can see at birth, That is what they look like. So again, external genitalia female. I'm not sure what happened there. But then they hit puberty. So I think that's age 19, actually. They clearly went from a very girl-like appearance to a very male typical appearance as an adult. Oh, I thought this was kind of fun. So this little point down here. Um, so that the drug finasteride, um, that helps males shrink their prostate. As males get older, prostates naturally grow. So this is a medication that's often given to elderly males. The way that it works is by inhibiting 5-alpha reductase. So I thought that was kind of cool. Anyway, as I stumble over my words, little known fact. Okay. Then there's also something where we get into an additional chromosome. So one of those trisomies is called Klinefelter syndrome. So you can kind of see there's an XXY, right? So that extra X can impact how the individual appears. Now, because the Y is there, there is enough testosterone production. The Wolffian duct systems, do form. However, due to that extra X, a lot of times the individual may have low sperm production and lower testosterone levels. Sometimes, again, this is one of those things that has like a continuum on it, where depending on how affected the individual is, they might be infertile, they may not be. But that low testosterone can lead to delayed puberty. It can lead to breast enlargement, a decreased muscle mass, bone density, kind of more female typic. And then there's also some other developmental, like cognitive kinds of, impairments that are associated with that. So anywhere from like mood kinds of things like anxiety, depression, to learning disorders, or somewhere being on the autism spectrum. Then there's the opposite, XYY. So XYY syndromes or Jacob's syndrome. And now in this case, so you have an extra Y. So there's usually sort of obvious telltale signs of an individual who has XYY. They may have increased height. However, like they have interestingly like a weak muscle tone, larger than typical teeth, flat feet. Again, there's some associated cognitive or behavioral kinds of, things that go along with this. So there might be anxiety, excessive aggression, impulsivity, some learning disabilities that go along with that. There was this famous study, oh gosh, it must have been in the 70s, about individuals with XYY. So I'll just tell you briefly, like they thought that people who had, so what they thought was, all right, so people who have XYY, that extra Y, they should, and they're tall, they're aggressive. We should find a lot more of these people in jails, right? Like in prison, because those are the violent people, and these people, are violent because, oh my God, why? And sure enough, they went into the prisons, and there's a very, at the time at least, so there was a larger than, a larger statistical number of people in prisons who are XYY than the regular everyday population. And so the study said, well, oh, look, see, we knew it, that extra Y chromosome made people like really aggressive and bad and raw, extra testosterone. Okay. Well, it turns out that, all right, and then someone went, well, wait a second, you're putting your own sort of biases on the study. And so they went back and they looked at it a little bit closer. And what they realized was that it had nothing to do with like the Y making people like, abnormally make them commit crimes. So they were not like morally derelict or something like that because of this Y chromosome. What it was that these people, they were really tall, and they kind of had, flat feet. Doesn't make you the best runner out there. So when people who were XYY, they were easier to catch, and then they stuck out in the lineup. So people you're kind of easy to identify, especially if they have these really big teeth too. So it wasn't that they committed more crimes, they were just caught easier than your average person who could hide in a crowd. These people couldn't. So it was this really good example of where statistical bias and sampling error can like lead to the wrong conclusion. So there's nothing that inherently makes these people more criminal like. It's just, again, they're easier to catch and identify when you have a very unique appearance. Okay. So that's the end of that. Hopefully this was somewhat insightful to you, give you an idea of like how hormones can influence the reproductive system and then our people's appearances, as well as some of their identities, and give you a little bit more background on that. So after this, we'll go on to the reproductive system, and I will see you guys there.